Good morning, everyone. I am Karan TGS of Sri Venkateswara College of Engineering, 7th Sem Electronics and Communication Engineering. I am here to do a topic on automotive electronics, and the topic is CAN, LIN, Modbus protocol, and message frame format, etc. CAN bus protocol and message format. The CAN bus system enables the ECU to communicate with all ECUs with complex dedicated wiring. Especially an ECU can prepare and broadcast information via the CAN bus. The broadcast data is abstracted by all other ECUs on the CAN network, and each ECU can then check the data and decide whether to receive or ignore it. These are the diagrams: application, presentation, session, transport, network, data link, etc. And CAN bus layer: logical link control, media access control, physical media attachment, physical media dependent, engine ECU, transmission ECU, ESP, ACC, sensor CAN, gateway, etc. are these components. What is CAN frame? Communication over the CAN bus is done via CAN frames. Below the standards CAN frame with 11 bits identifiers, which is a type used in most cars. The extended 29-bit identifier frame is identical except the longer ID. For heavy duty vehicles, SOF. The start of frame is the dominant 0 to tell the nodes that can mode intent to top ID. The ID is the frame identifier, low values, higher values priority. The remote transmission request indicates whether a node sends data or request dedicated from another node. The control contains the identifier extension bit, which is a dominant 0 bit for 11 bit. It also contains 11 bits data length code that specifies the length of the data bytes to the transmitted. The data contains the data bytes ACA payload, which includes scan signals that can be extracted and decoded from information. CRC, the cyclic renary check, is used. ACK slots indicates that node has not. The UF makes the end of the CAN frame. LIN bus protocol and message format. Low cost option, often used in vehicles for windows, wipers, air conditions. LIN clusters consist of one frame, mostly up to 16 slave nodes. Single wire with 1 to 20 bytes, max 40 bus length. Time triggered scheduling with guaranteed latency time, variable data length. Lin supports error detection, checksum and configuration. Operating voltage of 12 volts. Physical layer based on ISO 9141. Sleep mode and wake up support. Most newer vehicles have 10 plus Lin nodes. These are the Lin master node header response. Bootloader application UDS ISO 14229 YSO 15765 Lin TP can stack Lin ANM Lin IF Lin CT. What is Lin bus frame format? Break a sync identifier data checksum. Break. The sync break field is a car break is minimum 13 plus 1 bits long. The break field acts as a start of the frame notice to all Lin nodes on the bus. Sync. The 8-bit sync field has a predefined value of 0 into 55. This structure allows the Lin nodes to determine the time between rising, falling edges and thus the baud rate used by the master node. This lets each of them stay in sync. Identifier. The identifier is 6 bits followed by the two parity bits. The ID acts as an identifier for each Lin message sent and which nodes react to headers. Slaves determine the validity of the ID field and act via below. Ignore the subsequent data transmission. Listen to the data transmitted from another node. Publish data in response to the later data. When a lin slave is polled by a master, it can respond by transmitting 2 or 4 or 8 bytes of data. The data length can be customized, but it is typically linked to the ID range. The data bytes contain the actual information being communicated in the form of lin signals. The lin signals are packed within the data bytes and may be, for example, just one bit long or multiple bytes. Checksum. As in CAN, a checksum will ensure that the classic of 8-bit checksum is based on summing the data bytes only, while the enhanced checksum algorithm also used includes the identifier field. Most bus protocol and message format. The automotive most bus is a high-speed multimedia network that enables seamless communication between various components with the vehicle. It serves as a backbone of transmitting audio, video, and control signal, facilitating the integration of informant drivers in other vehicle systems. The most bus was designed to carry high bandwidth multimedia data over the vehicle. It was initially specified in the 1990s throughout the joint efforts from BMW Baker Oasis Silicon. Over time, the consortium expanded to include more members, and today many OEMs use the automotive mouse bus to carry their multimedia. This is a diagram. Media-oriented system transport frame format. The media-oriented system transport uses a specific frame format for transmitting data and control signals between network nodes. Understanding this frame format is essential for analyzing and interpreting the data exchanged on the bus. The frame format of most 25 protocol consists of 1 byte header with 4 bits used as a synchronization purpose. The remaining bits in the header indicate the number of quads available for streaming data in the packet. Control data and the frame control follow the header, with the size of each control message being 32 bytes. The most 50 and most 150 protocols have different frame format, but they share similarities with the most 25 format. The header of the most 50 format contains 11 bytes, including subfields such as administrations, logback, control data. The most 150 header is similar to most 50 header, but includes an additional byte for frameable information. This is the diagram. Thank you.